Here's another example of using an ICE table to solve an equilibrium problem. And this one's a little more complicated, so you'll want to play this again if you don't understand it. So for the reaction of H2 plus I2 goes in equilibrium with 2HI at a certain temperature, the value of K of the equilibrium constant is 56. If the initial concentration of H2 is 0.0175 moles per liter and if I2 is 0.0175 moles per liter, what will be the equilibrium concentrations of each reactant and product? So the first thing we're going to want to do is put the equation into our table. Don't worry, that was a chemistry test for grade 9. Okay, H2 plus I2 is in equilibrium with 2HI. Okay, so right away we see this 2 here. This is going to play an important role. So from our question, it said initially we had initial concentrations. And notice that they're the same. That kind of makes sense. 0. Oops, I forgot a 0. Moles per liter. I'll just do a big M. How's that sound? Okay, that's because they're in the same ratio, so chances are they're the same. It says there's nothing of this present. Okay, that's the initial concentration. So how it's going to change is this is going to go down by some number x, and this is going to increase by 2x. That 2 came from right here. Okay, so at equilibrium, we have 0.0175 minus x, 0.0175 minus x. So I've just combined these two. And I have 0 plus 2x, I just have 2x. Okay, we know that the equilibrium constant is the ratio of the products, and then you raise it to the power of that coefficient. So look, that 2 came in again right here. We divide that by the reactants, the concentration of the reactants. Okay, so now it's just a matter of putting in the values that were given. From the question, it says the value of Kc is 56, so that's the first number we're going to put in. The concentration of Hi from our table is 2x, and we take that and we square it. Okay. The concentration of H2 is 0.0175 minus x. The concentration of, sorry, this should have been I2. If I was doing this in class, someone would have corrected me. The concentration of I2 is 0.0175 minus x. Okay. Now, here we have an equation. We're going to try and get rid of the fractions, and then we're going to try and solve. I already see that it's a quadratic, okay? Quadratics, there's many ways we can solve quadratics. We're going to use the quadratic formula. So hopefully that rings a bell from something. Okay. What's going to happen here is we are going to go 56, and then we're going to multiply both sides by this denominator to get rid of it. 0.0175 minus x, 0.0175 minus x. That is all equal to 2x squared. Well, 2x squared, all squared is 4x. This is a mistake kids make. Most of them will just say 2x squared, but no, we're squaring the whole thing. 2 squared is 4, x squared is x squared. Okay? Now we need to do some foiling. Okay? So, I'm going to leave this 56 out. Foiling means first, outside, inside, last. Whenever you have two binomials multiplied together, you should get a trinomial when it's all said and done. Okay, so hopefully you've squared things before and you'll see the pattern. 0.0175 squared. We're going to minus 2. 0.0175 x plus x squared equals 4x squared. Now I'm going to distribute this 56. Okay? When I distribute the 56 and I'm going to square, I'm going to multiply things together. Okay? So I get 0.01715. That's when I went 0.0175 squared and times by 56. I got this number. Okay? Minus 1.96x. So I went 56 times negative 2 times 0.0175x. That's the number I got here. Plus 56x squared equals 4x squared. Okay, now I want to combine some like terms. The only like terms it looks like I have are the x squared. I'm going to bring them all so I have a positive x squared. It's easier to put in the quadratic formula then. So I'm going to subtract 4x squared from both sides. Okay, so I have 56x squared minus 4x squared. That leaves me with 52x squared. Okay, I still have my minus 1.96x, and I have my 0.01715. So I have this term, and I combine those terms. On this side, I have 0. Now I can use the quadratic formula. Okay, let's remember x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Now what are the values of a, b, and c? A is the number in front of the x squared term. B is the number in front of the x term. And c is the number with no variable. So what we're going to do now is we're going to put these values in and we're going to solve this equation. This is where kids make mistakes. We have to do lots of order of operation. We have to make sure if we do this on our calculator, we have a bunch of brackets. Okay, so let's sub in our values. X equals negative. Now we take b. b is negative 1.96 plus or minus. Remember, there can always be two roots of a quadratic. Square root of b squared. So we put b in. Minus 4a. A is 52. C is 0.01715. All of this is divided by 2 times a, which is 52. Okay. Well, when I have negative 1.96, that's just going to become positive. Okay? Over here, I did everything underneath the brackets. Negative 1.96 squared, and then I went to minus 4 times 52 times 0.01715. And I got 0.2744 divided by 104. So there's two cases. I have to go through and do this once where I add this together and once when I subtract. Okay, so the first value I got was 0.023883. The second value was 0.0138. And I encourage you to pause the video right now, take out your calculator, and make sure you can get these two values. You have to be able to do the quadratic formula. Okay, and if there's a problem, ask a math teacher for help, or ask me, show me. Maybe I can make another video, or I can try and walk you through it on your particular calculator. Okay, but make sure these two answers come. So we're going to have to reject one of these. If we look at what we were doing with x, we put 0.175 minus x. Well, if I did 0.175 minus 0.023, I would get a negative value, and it doesn't make sense that I'd have a negative concentration. So this one I'm going to reject, and there'll always be one that you reject, okay? Why? Since it's bigger, than the concentration of H2 or HI, which was 0.0175. Okay, because if I subtracted that, I would get a negative. So we're going to reject this one. So this is the value of x we are going to use. Okay, just like the previous example, we're not done. So we have to find, it's asking us the equilibrium concentrations. We need to sub into our equilibrium to get our answer. Okay, so let's just a little bit more math. So the concentration of H2 and I2, which are both the same, that's what these square brackets mean, is concentration. Okay, is equal to 0.0175. Do I have that right? I just have to do a quick check. Yeah. Minus 0.0138. And so we need to do that calculation. Oops. Clear, clear, clear. I don't know how to clear. There we go. So 0.0175 minus 0.0138, 0.037. 2 zeros. Moles per liter, or just big M. Okay, and the concentration of HI is 2x. So 2x, which would be 2 times 0.0138, which is equal to 0.0276 moles per liter. Okay, so there's our final answer. So, quadratic formula. That's why we learned all these math skills. So give this a try. Let me know if you have problems. Ask a math teacher for help or myself.